So what is a normal? Well, to explain what a normal is, we're going to take a look at this cube. Every face of any mesh has a direction, and this is called a normal. A normal refers to the direction a face is pointing, relative to itself. So ideally, I want all of my normals to be facing outside in Blender. If the normals are facing outside, like they should be, they will be represented with a blue line or a blue face. In our 3D viewport, if we want to set up the ability to see our normals, the first way is to use a colorway of seeing our normals, where blue will mean that the normals are facing outside and red will mean they're facing inside. On this cube, we want all the normals to be facing outside, since we're seeing the outside of the cube. So under my overlay tab, these two circles, there's a drop down arrow, and underneath a left click face orientation. And now you can see by default, all the faces are blue. If I zoom right into this object and clip through it, you can see inside the cube, the faces are red, and this is because they're the inside facing normals. Another way we can see normal direction is by going into edit mode, and we can enable this option down here for normals. You can see we've got a few different types, and we're going to want to click face, which is this third option here. And now you can see there's these blue lines pointing out. This means that normals are facing outside. If I were to press A to select all the faces, then left click mesh, normals, and press recalculate inside, now you can see those blue lines have disappeared and our faces are now red. And this is because the outside of the normals is now the wrong way around. I'll press Ctrl Z to undo that. If the normals are facing inward like this, they are called flipped normals. Normals facing the right way or outside is important for a few reasons. The first thing is it can cause shading issues if the normals are not facing outside. As well as that, you can also experience issues with certain types of modifiers and normal data on your material. So how do we fix flipped normals? If I come back to my cube and I'm going to go to mesh, then normals, recalculate inside to make sure the normals are the wrong way around. And you could do this even if only some of the faces were facing the right way. So let's say for example, I left click one of these faces and left click mesh, then normals, and then I do recalculate outside. You can see this face is now being returned to the right way around. You can also press A to select everything and press Shift N, and that will recalculate everything we have selected. So essentially, you want all these faces to be blue and to have one of those blue lines if you have that option enabled. And this should fix up a lot of shading issues and stuff you may be having with your model. When I'm modeling, I may stop and recalculate the normals outside if I feel like experiencing some shading issues. Blender is really good at recalculating normals, but in the off chance that Blender misses a face, we can click on it and then click recalculate inside, since essentially what that'll do is flip it no matter what. So you might be wondering then, how exactly do normals relate to normal maps? Well, if we look at a normal map, there are various colours, mostly bluish and reddish colours. Normal maps work in RGB, and like we've covered previously in our vectors video, RGB represents X, Y, Z respectively, red being X, green being Y, and blue being Z. So since normal maps hold RGB info, that info can be used as vector info, stored as XYZ, since RGB and XYZ can translate to one another. As some of you might have figured out, this is why normal info uses the bluish purple socket. When we apply this normal map to the cube, it will alter the shape of the normal at a small pixel level. So each face for this unwrap will alter its respective face on the geometry by rotating and moving the normal around at a pixel level. This creates the illusion of more geometry, but it's actually just one face with its normal altered at a pixel level. So each pixel will have a vector with a RGB/XYZ. This vector acts like coordinates to determine each pixel's orientation. I like to think of a normal as being able to be deformed like Play-Doh into a unique detailed normal, and to control this deformation we can use a normal map or some sort of normal input. For example, this bump node, essentially what's happening is it's translating bump info into normal information. We will cover bump in greater detail in the next episode. What makes normal information even more amazing, whether that's through using a bump node or a normal map node, is that the altered normal will react to light and material changes, just like a modeled geometry, even though this face is just 4 vertices. It's also worth noting that there are 2 main types of normal maps. These are OpenGL and DirectX, although keep in mind that different types of 3D software will have a different default normal map. So in Blender, we use OpenGL by default, which means if we have a DirectX normal map, we have to do an extra step in order to make it work in Blender. Fortunately, this is fairly straightforward. As always, we're going to make sure our normal map is set to non-color in the color space. Then I'm going to press Shift A, then under Converter, I'm going to left click, Separate Color. This used to be called Separate RGB, so that might be what it's called in your version. Then I'll plug my color into the color, and now I'm going to press Shift A, and I'm going to search for Combine, and I'll left click Combine Color. Now we're just going to connect the red to the red, blue to the blue. I'm going to leave the green just now, since the difference between DirectX and OpenGL normal maps is DirectX normal maps have a flipped green channel compared to OpenGL. Also, like we do for any normal map, we will need the normal map node. So I'll go into Vector and left click Normal Map. I'll leave the strength at 1 and I'll plug my normal into the normal of my shader and color into my color. Then in order to get this DirectX normal map to work, all I'm going to do is press Shift A and I'm going to search for Invert. You'll notice that the invert is a color socket, which means we can invert color channel. Then I can plug my green into color and color into green. And now we have inverted the green channel and essentially turned this DirectX normal map into an OpenGL compatible normal map. Finally, I'm going to cover what Shade Smooth is, also known as Phong shading. So essentially what Shade Smooth does is it averages out the normals. So if I take my cube here, go into object mode and press right click and Shade Smooth, you can see it creates this weird effect. And that's because it is averaging out the shading of the normals. You may have heard before, or heard myself mention this, but if we come down into our green triangle here, then under normals, left click auto smooth, that fixes things up. And that's because we've now set an angle limit, which essentially makes it for if the angle is 30 degrees or more, it won't shade smooth. If I right click and subdivide this cube and turn up the subdivisions a couple of times, and I'll select this face here and press O to turn on proportional editing, then press G and X to bring this out. You can see when I go back into object mode that this thing has been shaded smoothly. Although if I was to lower my angle, eventually it would start shading flat again. And that's because these angles are around 5 degrees or less. So I usually keep this at 30, but it's good to know how this auto smooth function works. Since we're essentially averaging out the normals here, if I was to press Shift A and add another cube and right click and shade smooth, you'll notice that the shade smooth will fix itself if I was to, for example, bevel all these faces here. You can see how much better that looks now. Then we would essentially be improving it more and more by adding loops and more geometry, since each one of these faces will be taken into consideration when calculating the shade smooth. Now we're going to have a quick quiz. Well done for completing the tutorial so far. Number 1, how does shade smooth work? Number 2, how do normal maps alter the normals of the mesh it's applied to? Number 3, how can we visually see if normals are facing the right way? I'll be answering the questions in 15 seconds from now. Number 1, how does shade smooth work? By averaging out the normals and smoothing it out that way. We can also use the auto smooth function to limit the angle where shade smooth will be applied to. This is really useful because on a cube, for example, we wouldn't want to have these faces smoothed out since the angle is really high and it wouldn't make sense for it to be smoothed out. So we can turn on auto smooth, which will make it so any angle bigger than 30 won't be smooth. Number 2, how does a normal map alter the normals of the mesh it's applied to? A normal map will alter each normal of the face at a pixel level, and this will be determined by the normal map we plug it into. Cool thing about this is lighting and materials will affect this normal effect as if it were modeled geometry, which makes normal maps really powerful. Number 3, how can we visually see if our normals are facing the right way? The first way to do this is to enable the colored faced orientation in this drop down here in either object or edit mode. The second way is just in edit mode, where we enable our normal direction blue line here, which will show us if our normals are facing outside or not. Since we need our normals to be facing the right way in order for our shading and certain modifiers to work properly. Great job everyone for completing this tutorial. In the next episode, we're going to be covering displacement and bump in a little bit more detail. Also, if you want to write down your answers to the quiz, or you have any questions for me about this tutorial, feel free to let me know in the description below. With that though, I would like to thank you all very much for watching, and I'll see you all in the next tutorial. Take care.